In this video, we are going to learn how to recognize geometric sequences, and we're going to learn how to find a formula or a rule that will give us any term of the geometric sequence. And that all begins right now. Bet you can't wait. So here's the deal. A list of numbers like this is a sequence. And some sequences follow a specific pattern that gives them a special name. One of those is geometric. Now, a sequence is geometric if it has a common ratio from term to term. That means if you take each term and divide by the previous term, you should get the same number over and over again. So let's check and see if number 18 is geometric. Each term divided by the previous term. So, for example, if I do 12 divided by -2, that's -6. All right? How about the next pair? If I do -72 divided by 12, okay, that is also -6. All right? Now, if I do the next pair, 432 divided by -72. Now feel free to type this into a 4-function calculator, but I think you will find that this is also -6. So because you get the same number every time you divide each term by the previous term, that means that it is geometric. So we can just label this geometric. And if it is geometric, we're supposed to find the common ratio and the 7th term and write the formula. If it wasn't geometric, we would just say not geometric and we'd stop. So the common ratio is the thing we just found. We write R for the common ratio. So R is equal to -6. Now for the rule. Okay. When you write the rule of a geometric sequence, it always goes like this. First of all, instead of using f of x or y equals, when you're writing the rule of a sequence, you always start out by writing a sub n. Okay, a n. Because if you write a and then a number next to it, like for example, a3, A3 represents the third term of the sequence. So for example, in this case, A3 is -72, A4, A2, A1. Okay? So AN means any term you want. So in general, here's how you do it. That was supposed to be an eraser. Okay, so to find any term you want, you're going to start by writing the first term, right? A1 would be the first term. And then you use the common ratio and you raise that to the n-1 power. So this is like the general formula for finding the rule. Now, so for this particular problem, -2 is the first term, so I'll put a -2 right here. The common ratio is -6. So I'll put my -6 right here. And then we just put n-1 up here. Alright, do not plug in 7. Leave it as n. Because it's a formula. We don't just want to find the 7th term. We want a rule for any term. 7th term, 10th term, 100th term. Now, so we are supposed to find the 7th term. So the 7th term would be written as A7. So we'll go ahead and put that. So if we're going to find it, we will use this formula that we just got. So if I want to find the 7th term, so A7 is going to equal -2 times -6 to the 7-1 power. I'm putting 7 in for n. So that's going to give me -2 times -6 to the 6th power. 7 minus 1 is 6. So, do I multiply first? No. Exponents come before multiplication. So I need to do negative 6 to the 6th power. So I'm going to keep this negative 2 for now. So consult your table. 6 to the 6th power is 46,656. Okay, am I sure that's what it was? 46,656. All right, notice it is no longer negative. When you raise a negative number to an even power, it's going to become positive. And now I will multiply by negative 2 to get my final answer, and I'll put it here. So I will use a calculator for this. So just understand at this point we're typing into a 4-function calculator. We're not allowed to use a scientific calculator. We are going old school. So negative 2, well, we know the answer is going to be negative. So in your 4-function calculator, you would just do 2 times 46,656. So that's going to be negative 93,312. Okay, so that is it for problem number 18. So we'll do the same thing for problem number 19. So first of all, is it geometric in the first place? If it's not, I can just say not geometric and go home. So we'll divide each term by the previous term to find it out. So for example, if I do negative 6 over 2, all right, that is negative 3. If I do 18 over negative 6, each term divided by the previous term, that is negative 3. And if I do negative 54 divided by 18, I would need to put this in my calculator, but again, I will get negative 3. So because we're getting the same ratio, a common ratio, if you will, then that means this is in fact geometric once again. So, is it geometric? Yes, it is. Now, since it is, we're going to find these things. So, the common ratio is what we just found to be, it was negative 3. So, that means we can easily write the rule. AN equals. You start with the first term, which is 2. And then you put the common ratio. Okay, and then you put to the n minus 1 power. Alright, that is the rule. Do not put a 7 right here. Not for the rule. The rule is supposed to give you any term, not just the 7th term. So don't put a 7 here. Now, we do want to find the 7th term, so we will go ahead and substitute that in. You know what, I'm just going to keep it like this. I'll do the calculations up here. So if I want to find the 7th term, that would be denoted A7. So I'll do the calculations up here. So for A7, I'm just going to put 7 in. So that's going to be 2 times negative 3 to the 7 minus 1 power. So that's 2 times negative 3 to the 6th power. Alright, so that's 2 times something. Now I know it's going to be positive. If you take a negative number and raise it to an even power, it's going to turn positive. So what is negative 3 to the 6th power? Well, we're going to use this table. So 3 to the 6th power is 729. So I'm going to have 2 times 729. And that is going to give me the answer. And I will use my 4-function calculator. 2 times 729 is 1,458. Alright, so that is how you do geometric sequences. By the way, the reason why we are doing geometric sequences in the middle of a unit about exponential functions is because notice that these rules are exponential functions. All right. In general, an exponential function will go like this. We'll have a times b to the x power, and there can be a shifting, with a minus h and a plus k. All right, but that's exactly what we have here. -2 is our a value. -6 here is our b value, and x minus h plus k. You can see that h is 1 and k is 0. So this is an exponential function. That's why we're bringing it up.